part A of this one, we're supposed to find the area of this shaded region R. Now, what I'm gonna do is I'm gonna do that 1/2 R squared formula from this windshield wiper of pi over 3 all the way to this windshield wiper of 5 pi over 3. But I'm just gonna do like that R equals 4 equation. Now, if I just do that R equals 4, so if I set up this, I do 1/2 times that 4 squared from pi over 3 to 5 pi over 3. What that gives me, it gives me this R, but it also gives me this extra sliver right here that I do not want, because that's going to go all the way out to the R going from here to here. So it's giving you all of that stuff filled in. Now, what we want to do is subtract out this little sliver. So if I just want this little sliver, that's from this windshield wiper to this windshield wiper, but you're traveling along this polar curve here, which is this harder looking equation there. So that's why I'm going to subtract that out. And that's what that's represented. It's 1/2 times the other R squared from pi over 3 to 5 pi over 3. We'll subtract that out because we do not want that. Now, this is a no calculator problem, right? A lot of times this polar one or parametric stuff will be on the calculator part of the test, but this is one where it's on the no calculator part. So they didn't want us to actually integrate that. That's nice. I just have to set it up and be done with it. Now, for letter B, letter B says find the slope of the line tangent to the graph. Okay, now slope of the line tangent to the graph, that's like the dy dx. So this is kind of merging a little bit with the parametric and polar stuff there. The dy dx is dy d theta over dx d theta. Now, this formula that I got right here, this is in your notes. When you first watch that video over the BC Extra video lectures, your very first video over parametric and polar stuff, this was in there. Now, when I worked this problem out, this is like the first time I ever saw that thing pop up on the actual AP test there. It was a long time ago. I saw it one other time there, but I haven't seen it. I thought it disappeared. Now, so I didn't quite remember this formula off the top of my head right here. But if you think about it, this is the derivative of y's with respect to theta. That's the derivative of x's with respect to theta. Now, remember the y's is the same thing as r sine of theta, and the x's is the same thing as r cosine theta. So I really just want to do the derivative of that. And so even if you didn't remember that formula off the top of your head, because it's a little lengthy of a formula, right? All you got to do is do a product rule right there. So I did first function times it by the derivative of the second, plus the second function times it by the derivative of the first. And I did another product rule down here, and then boom, that derivative just is right there. So I don't even think I mentioned that. That's just your product rule when I first gave you the video over that. And now, so the R is that equation that they tell us to use, right? And then they also say at the pi over 2. So then I took the derivative of that, and so I have my R prime. So I was able to plug those in and then plug in the pi over 2. And so sine of pi over 2 is 1, cosine pi over 2 is 0. So just the rest of that, I just want you to practice the arithmetic in your head, or writing that down, like, without the calculator, and see if you're able to get that number. But like I said, make sure you just do the derivative there and then show your setup and everything like that. That way, if we happen to make a little mistake, you got a bunch of points and stuff on there. All right, now letter C. Actually, I kind of like letter C better than the other parts of that problem there, okay? I know there's a big giant paragraph here, but this is actually a pretty easy, like basic related rate type thing, okay? So we got this particle moving along the curve, and then the distance between the particle and the origin. Now, the distance between that particle and the origin, that's what the R is. That's what the R represents, is the distance between the particle and the origin, the distance between the origin and the actual curve. So when they tell you that that's changing at a rate of 3 units per second, they're giving us that's the dr dt, not a d theta dt. And so that's your dr dt is a 3, and then we have the r. And then you want to find the rate of change of the angle with respect to time. So that's another hint that they didn't give you that yet. You want to find that in symbols as the d theta dt when that theta is power 3. So basically, you just turn this into a basic related rate problem that we did a long time ago. And now, if you're going to take the derivative with respect to time, all right, so you do your normal derivative, and then you're doing the derivative of thetas with respect to time. So you got to tag on that d theta dt. And then once you do that, plug in the 3 for the dr dt, plug in the pi over 3 for the theta, simplify that and solve that for the d theta dt. And remember, the d theta dt is always in radians per second right there. So I thought this was a little bit different. We haven't seen that for a very long time. We've seen stuff like this before there, just getting more comfortable with that polar area. And then this, just because it's letter C, doesn't necessarily mean it's going to be the hardest part of the problem. Just because there's a bunch of words in there, that's actually a pretty good related rate problem. I like that there. Pool table, billiards, 8 ball,